The AI race is heating up once more, but not in the way you might expect. Microsoft is working on their own chips that will compete with Nvidia's, but we're going to be honest with you. Before we show you all the specifics of Nvidia's chips, you should really take a look at how far ahead they are. Stick with us till the end of the video because you definitely wouldn't want to miss out on this. I need to explain to everyone why Microsoft's new secret chip, and later in the video even Google's new secret chip, which they claim is quicker than Nvidia's, are crucial to a ChatGPT and Air software, so that you all understand exactly what ChatGPT is and how these chips work. The interesting thing is that AI is actually learned through a process known as deep learning, which involves teaching AI networks with large data sets to learn from and examples to make predictions or decisions. Essentially, you know how people feed it large amounts of data and in the middle of their journey how they fit at loads of pictures? That's how these programs are run. Of course, these processes are computationally intensive and require sharing massive amounts of data and computation. The chips that Nvidia produces are highly scalable, making them suitable for large machine learning applications, which essentially means that these are the kind of chips that we need to power the next generation of AI. What's also cool about these chips is that they have tensor cores, which are designed to accelerate matrix math operations, which are central to many deep learning algorithms. In other words, these chips are fundamental to the coming fourth industrial revolution, and you must realize that without them, progress in AI will be extremely difficult. Now here's the thing. Nvidia makes these chips, and they're pretty much the best chips money can buy. They recently had the A100 chip, which was a respectable chip, but even recently, Nvidia upped the bar once more with the H100 chip that you're currently viewing on the screen. Here's the issue now. Okay, so Nvidia is just one manufacturer of these chips, and you can see right here on eBay that they are extremely expensive and in high demand. What's even stranger is that you can see right here that the cost of training GBG3 was around $4 million, which is absolutely insane. What's worse is that OpenAI spends about $3 million per month to maintain ChatGPT, and that's just based on the many courses that come with running the system. You must realize that if these businesses can't develop their own chips that they can manufacture internally, they will be completely dependent on Nvidia. If Microsoft is dependent on Nvidia, they won't be able to compete because, of course, that will be a significant expense that they must continue to incur, and of course, Nvidia will be the only one making all of the profits. Since everyone is aware that large language models are going to be popular in the future, and that the company that masters those chips will essentially be powering pretty much the entire world to large language models because they won't have a choice, businesses like Microsoft and businesses like Google are competing to create their own chips. This is due to the fact that if they produce their own chips, they will be less dependent on the behemoth that is Nvidia. Of course, we already know that these businesses want to create these products as soon as possible as massive language models become increasingly scalable and more complex. Now that you are aware of what these AI chips are used for, let's talk about Microsoft's Athena. According to sources, 300 people are currently working on these chips, and next year, Microsoft and OpenAI may begin using them more widely. However, they are unsure of whether they want this chip to be made available to cloud computing customers. This article also claims that OpenAI has used Microsoft supercomputers to train its robots. If you don't realize how expensive these models are, remember that every time you go on ChatGPT, and even if you are a Plus subscriber, you try and access GPT-4, you see this message right here. It says GPT-4 currently has a message cap of 25 messages every 3 hours. I'm pretty sure that's largely due to the fact that these computers actually run on Nvidia's chips. Google has been teasing its TPU-4 chip, which is insane because they actually claimed that it was faster than Nvidia's model, the A100, which is very, very quick and is specialized in deep learning and A1 capabilities. Recall from earlier in the video that Microsoft isn't the only company developing its chips, sources claim. In a recent scientific study, Google details the performance of their cloud TPU supercomputing platform, stating that it offers enhanced efficiency and additional skill performance for machine learning over Nvidia's A100. In a similar size system, the authors of this research claim that the TPU-4 is 1.2 to 1.7 times faster and uses 1.3 to 1.9 times less power than the Nvidia A100. Due to their expensive price tag and limited availability, they haven't actually compared this to Nvidia's H100 GPU. However, you might be wondering how powerful these graphics cards are when compared to Google's Cloud CPU V4 supercomputing platform, which is where they're trying to build this machine learning infrastructure. Well, just take a look because it's pretty impressive. The Hopper architecture speeds up AI, so the new H100 GPU from Nvidia is essentially 9 times to 30 times faster on training AI, which is absolutely incredible. The reason I say this is incredible is because you have to remember that while this is faster than the previous GPU, Google recently boasted about how their own GPUs were faster than Nvidia's A100s. However, Nvidia just released the H100, which is actually 9 times and 30 times faster in some aspects, which I find incredible. I do believe that it is important to note the role that these GPUs and that these chips will play in advancing this and making everything much more quickly, because eventually we do want to have this in real time. I mean, ChatGPT is great, but what you're not paying attention to is of course the hardware side, in which these companies are racing forward to develop these chips that are literally going to power the next industrial revolution, which many are referring to as AI, and I do think that it is important to note the role that those play. Brain-like computing and spiking neural networks frequently appear in our recommended feeds these days, and we're about to tell you why. Let me explain why this is literally the next level in artificial intelligence, and why once this technology is mastered, we're about to see a major breakthrough. I want to briefly touch on another amazing development in technology that is now in development. It therefore entails developing synthetic neural networks that can process information similarly to how the brain does. Basically, the brain, as you are aware, is made up of neurons, which are cells that transmit information. When a neuron receives a signal, it sends out its own signal to other neurons. This process of signaling between neurons allows the brain to process and interpret information. Now, neuromorphic artificial neural networks, NANs, are neural networks that mimic how neurons process information. Artificial neurons are made and then connected in a network so that they operate like genuine neurons so that they may send and receive information. It's a relatively new field, but this video delves into a lot of topics like 2D materials, which are essentially materials that are so thin that they are literally called 2D materials because they're so thin. 2D materials are materials that are so thin that they are literally called them 2D materials because they're so thin. Companies like Intel are investing in and developing these applications because these are what will power the next AI transposition. And there you have it. What are your opinions on this? Feel free to let us know in the comments section below. And with that, we've come to the end of today's video. Thanks for watching. We'll see you in the next one.